Hi students, hope you are happy and spending your time usefully on the online classes. On the continuation of last class, we learned the commutative and associative properties of set operations. That is, A union B is equal to B union A, and A union B union C is equal to A union B union C, and A intersection B is equal to B intersection A, and A intersection B intersection C is equal to A intersection B intersection C. On this continuation, we are going to see the distributive and Demorgan's law in this class. The distributive property, in our lower classes we studied the distributive property of multiplication over addition on numbers. A into B plus C is equal to A into B plus A into C. In the same way, we can define the distributive property over sets. For any three sets A, B, C, A intersection in the bracket B union C close the bracket is equal to in the bracket A intersection B union in the bracket A intersection C. This is a distributive property of intersection over union. Then the distributive property of union over intersection is A union in the bracket B intersection C close the bracket equal to in the bracket A union B close the bracket intersection in the bracket A union B close the bracket. Using this property, we will see one example from the textbook. Example 1.21. If A is equal to 0, 2, 4, 6, 8 and set B is equal to x such that x is a prime number and x less than 11, and C is equal to x such that x belongs to n and x lies between 5 and 9 including 5 excluding 9, then verify A union in the bracket B intersection C is equal to in the bracket A union B complete the bracket intersection in the bracket A union C complete the bracket. In this problem, here the set A is given as straight away in the roster form with elements 0, 2, 4, 6, 8, but B is a prime number which is less than 11. So we have to write this in the roster form with 2, 3, 5, 7 as the elements of B, and C lies between 5 and 9 with elements 5, 6, 7 and 8. To verify the above distributive property, first in the left hand side we have to find B intersection C. Here the common element between the B and C are 5 and 7. So B intersection C is equal to 5, 7. Then we have to find the union of this set with A, which gives the value 0, 2, 4, 5, 6, 7 and 8. Okay, in the right hand side you have to find A union B. Here the A union B is 0, 2, 3, 4, 5, 6, 7, 8, and A union C is equal to 0, 2, 4, 5, 6, 7, 8. Then the intersection of these two sets gives 0, 2, 4, 5, 6, 7 and 8. If we observe the answers from 1 and 2, we arrive the verification of the above distributive property. Next we will see one more problem from the exercise 1.5. The third sum, A is equal to x such that x belongs to Z where x lies between -2 and 4, and B is equal to x such that x belongs to W, x less than or equal to 5, and C is equal to -4, -1, 0, 2, 3, 4. Then verify the distributive property. In this the set A and B are in the set builder form, so we have to write this in the roster form with set A is consist of -1, 0, 1, 2, 3 and 4, and set B consists 0, 1, 2, 3, 4 and 5. Set C consists of -4, -1, 0, 2, 3, 4. Then you have to find the B intersection C, which is in the left hand side. The common element between B and C is 0, 2, 3 and 4. Then the union of this set with A gives -1, 0, 1, 2, 3 and 4. To the right hand side, first you have to find A union B, which gives -1, 0, 1, 2, 3, 4 and 5. Then A union C gives -4, -1, 0, 1, 2, 3 and 4. Then the intersection of these two sets gives -1, 0, 1, 2, 3 and 4. Now we observe that the left hand side and the right hand side are equal. Now we have verified the above distributive property. Next we are going to see the Demorgan's laws for set difference. For any three sets A, B and C, first we have A minus B union C is equal to A minus B intersection A minus C. In this, in the left hand side we have union, the right hand side we have intersection. For the second one, we have A minus B intersection C is equal to A minus B union A minus C. So you have to read these two and by heart. Then the Demorgan's laws for complementation is, let U be the universal set containing finite sets A and B, then A union B whole dash is equal to A dash intersection B dash. Then the second property is A intersection B whole dash is equal to A dash union B dash. You have to thorough these laws also. With this we will see the example 1.24. If P is equal to X such that X belongs to W and X lies between 0 and 10, Q is a set X such that X is equal to 2n plus 1, n belongs to W and n less than 5, and R is equal to 2, 3, 5, 7, 11 and 13. Then verify P minus Q intersection R is equal to P minus Q union P minus R. Here the set P and Q are in the set builder form, so you have to write this in the rooster form. Here P is equal to 1, 2, 3, 4, 5, 6, 7, 8 and 9. Q is equal to 1, 3, 5, 7 and 9. You can get this by substituting the value of n as 0 in the above equation. X is equal to 2n plus 1. If you substitute 0, you will get 1. Then for n is equal to 1, you will get 3. For 2, you will get 5. For 3, you will get 7. And for 4, you will get 9. So the elements are 1, 3, 5, 7 and 9. Then R is in the rooster form itself. So first in the left hand side, you have to find Q intersection R. Here the Q intersection R is 3, 5, 7. Then you have to find P minus Q intersection R. To get this, we have to neglect the common elements between the set P and Q intersection R. Then you will get 1, 2, 4, 6 and 9. To the right hand side, first you have to find P minus Q. Here we have to neglect the common elements between P and Q. The first element is 1, then 3 and then 5, then 7 and 9. If you neglect this, you will get the remaining elements from the P as 2, 4, 6 and 8. Like that you have to find P minus R. Here the common elements are 2 and then 3 and then 5 and then 7. Then we have the remaining elements from the P as 1, 4, 6, 8 and 9. Now we are going to find the union of these two sets P minus Q and P minus R. We will get 1, 2, 4, 6, 8 and 9. From the equation 1 and 2, we arrive that P minus Q intersection R is equal to P minus Q union P minus R. Next, from the exercise we are going to see 7th sum. Here A is equal to minus 2, 0, 1, 3, 5 and B is equal to minus 1, 0, 2, 5, 6 and set C is equal to minus 1, 2, 5, 6, 7. Then show that A minus B union C is equal to A minus B intersection A minus C. First we are going to find B union C. Here we have to write the union of two sets minus 1, 0, 2, 5, 6, 7. Then the difference of this set with A gives minus 2, 1 and 3. Then A minus B is equal to minus 2, 1 and 3. And then A minus C is equal to minus 2, 0, 1, 3. Then the intersection of these two sets gives minus 2, 1, 3. Now look at the left hand side and the right hand side, we get same answer. Then you verified the Demorgan's law of set difference. Next we will see example 1.26, in which we are going to verify the Demorgan's laws for complementation. Here the universal set U is equal to X such that X belongs to Z, where X lies between -2 and 10. A is equal to X such that X is equal to 2P plus 1, where P belongs to Z. P lies between -1 and 4. And B is equal to X such that X is equal to 3Q plus 1, Q belongs to Z, and Q is equal to -1 to 4. Verify the Demorgan's laws for complementation. First we are going to find the universal set. Here the sets are in set builder form, so we have to write this in the rooster form. The integers between -2 and 10 are -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Then for A we have to substitute the values of -1, 0, 1, 2, 3, 4. Then you will get the value of A as -1, 1, 3, 5, 7 and 9. Like that, for B you have to substitute the value of Q as -1, 0, 1, 2, 3 in the equation 3Q plus 1. You will get the value of B as -2, 1, 4, 7 and 10. First we are going to verify the first law of complementation, which is A union B whole dash is equal to A dash intersection B dash. For that, first we are going to find A union B. Here A union B is all the elements from A and B. -2, -1, 1, 3, 4, 5, 7, 9 and 10. Then A union B whole dash is equal to 0, 2, 6, 8. You get this by eliminating the elements of A union B from universal. Then for A dash you will get -2, 0, 2, 4, 6, 8 and 10. By eliminating the elements of A, -1, 1, 3, 5, 7 and 9. The remaining elements are -2, 0, 2, 4, 6, 8 and 10. Like that, for B dash you have to eliminate the elements of B. Here -2, 1, 4, 7 and 10. The remaining elements from U are -1, 0, 2, 3, 5, 6, 8 and 9 gives B dash. Then A dash intersection B dash. The intersection is the common element between these two sets. Here the common elements are 0, 2, 6 and 8. So A dash intersection B dash gives 0, 2, 6 and 8. Now from the equation 1 and 2 we verified that A union B whole dash is equal to A dash intersection B dash. Next we will see the second law, which is A intersection B whole dash is equal to A dash union B dash. For the left hand side, first we have to find A intersection B, that is a common element between the sets, gives 1 and 7. Then A intersection B whole dash, you will get this by eliminating 1 and 7 from the universal set. If we eliminate this 1 and 7 from the universal set, we get the remaining elements as -2, -1, 0, 2, 3, 4, 5, 6, 8, 9 and 10. Then for the right hand side you have to find A dash union B dash. Already we find the A dash and B dash in the first law, so we have to find the union of those two sets. Here A dash and B dash are -2, 0, 2, 4, 6, 8 and 10, and B dash is -1, 0, 2, 3, 5, 6, 8, 9. If you take the union of those two sets, we get -2, -1, 0, 2, 3, 4, 5, 6, 8, 9 and 10. So from these two results 3 and 4, we verified that A intersection B whole dash is equal to A dash union B dash. Using these laws of complementation, we will do the 10th sum from the exercise. Here the set U contains 4, 7, 8, 10, 11, 12, 15, 16 and set A contains 7, 8, 11, 12 and B is equal to 4, 8, 12 and 15. Then verify the Demorgan's laws of complementation. So first law is equal to A union B whole dash is equal to A dash intersection B dash. To the left hand side, first we are going to find A union B. So all the elements from A and B are 4, 7, 8, 11, 12 and 15. Then A union B whole dash gives 10 and 16. To the right hand side, first we are going to find A dash. Here A dash is equal to 4, 10, 15 and 16. Then B dash. B dash is equal to 7, 10, 11 and 16. Then we have to find the intersection of these two sets. Here the common elements are 10 and 16. So A dash intersection B dash is equal to 10 and 16. Now observe the left hand side and the right hand side answer. We verified that A union B whole dash is equal to A dash intersection B dash. Next we are going to verify the second law. A intersection B whole dash is equal to A dash union B dash. For the left hand side, first we are going to find A intersection B. Here the common element between A and B are 8 and 12. Then A intersection B whole dash. We get this by eliminating 8 and 12 from the universal set. The remaining elements are 4, 7, 10, 11, 15 and 16. For the right hand side, we are going to find A dash union B dash. We already find A dash and B dash in the first law. Use those values. Here A dash is equal to 4, 10, 15 and 16. Then B dash is equal to 7, 10, 11 and 16. Then you have to find a union of these two sets. To write the union of these two sets, you have to combine all the elements of A dash and B dash. So A dash union B dash is equal to 4, 7, 10, 11, 15 and 16. Now if we observe the answers in left hand side and right hand side, they are equal. Hence we arrive the verification that A intersection B whole dash is equal to A dash union B dash. Now we recap what we studied in today's class. First one is distributive property. In that, first property is A union B intersection C is equal to A union B intersection A union C. The second property is A intersection B union C is equal to A intersection B union A intersection C. Then Demorgan's laws for set difference. In that, the first law is A minus B intersection C is equal to A minus B union A minus C. The second law is A minus B union C is equal to A minus B intersection A minus C. Then the Demorgan's laws for complementation. Here the first law is A union B whole dash is equal to A dash intersection B dash, and the second law is A intersection B whole dash is equal to A dash union B dash. I hope you are all understand all the problems and the properties we have seen in today's class. If you have any doubt, contact me. Practice all the problems what I have done and also do the assignment. We will see in the next class. Thank you.